Hello folks, this is Mr. T again, and today we're going to talk a little bit about theoretical probability, like my little finger, but we're going to talk about the simple events and the complement of event in this video, and then the follow-up videos will be for compound events which have independent pieces and dependent as part of that, and then look at that, and then conditional probability will be a different video, and then two-way tables will be a short little video as well. So that's what we're looking for in the next series of videos with this information. So let's get started with theoretical probability. Get back up here. Theoretical probability. We're going to start with the definitions and then look at 6 examples here that should be helpful to us. Okay? I enjoyed using my little pointy finger. Isn't it fun? Oh well, that's crazy Mr. T for you. Alright, so let's get my little pencil running here. So let's talk about this definition first thing. We've got probability is the measure of how likely an event is to occur. Event. Now what in the world is an event? Well, when it comes to probability, events are like flipping a coin, rolling a die, those sorts of things. Pulling a card out of a stack, pulling a marble out of a bag, a number out of a hat. Any kind of event where you're trying to predict the likelihood of something happening. Okay? Now, then the next thing here we have here, it says the set of all possible outcomes is called the sample space. Now, what's sample space? When it comes to a coin, it's heads and tails. That's all the choices you have. If you're rolling a die, you got number 1, 2, 3, 4, 5, 6 for a 6-sided die. That's all the choices that you have. That's called the sample space. Okay. For equally likely outcomes, okay, the theoretical probability of an event, P of E, that means P stands for probability, E is for whatever's going to be happening, okay? Probability of E, okay, is the ratio of the number of favorable outcomes to the total number of outcomes possible. So ratio fraction. So what's the chances of when you flip a coin to get heads? Well, it's 1 out of 2, so 1 over 2. So the favorable would be getting the heads on the top, and there's 2 possibilities, that's the bottom. So we'll do some more examples here as we go along. Okay, so a jar contains 32 red marbles and 28 blue marbles. What is the probability that a randomly selected marble is red? So how would that look like in that notation? So that's going to be the probability in this case of red. Okay, and let R stand for red. And so that's what that would look like. And so how many red marbles do we have? We have 32. And then what would be the denominator? Well, that's the total. So 28 plus 32, that is 60. Okay. And so this is our probability. It's a ratio of the favorable over the total possibilities. Okay. And so we're talking about the probability of one event at this time. Very simple, not getting too fancy. Oh, but it is a fraction, right? So we always need to reduce our fractions. And I see that we can reduce both of these by dividing both of them by 3. And when we do so, we get 8 over 15. Okay? And so that would be our probability right there. Okay? So let's go to our next example. So a letter in the word restoration is randomly selected. What is the probability of selecting a vowel? Well, how many vowels do we have? Okay, so we got E, O, A, I, and O. So that's 1, 2, 3, 4, 5 vowels. Okay, so that would be the probability. Now let's put V for vowel. Okay, and so we said that was 5 out of, and there's, if you count those up, that's 11 letters. Okay, all right, so that's our probability, 5 over 11. that fraction, or 5 out of 11 is how that's often said. And we need to reduce our fraction, but that's all there is to it. So that is our final answer right there. Okay, so let me go up here and move this down a little bit. Get a couple more examples. Let me see. Okay, for our next one, it says a day in the month of January is randomly selected. What is the probability of selecting a prime number? Okay, so let's see if I can find a picture of the month of January. Okay, so here is all the dates in January for 2020. Just pulled that calendar up. And what is a prime number? Well, a prime number is something that can only be multiplied by 1 in itself. Okay, so you would think that 1 would count, but they don't allow 1 to join into the game because it's part of the definition. Well, that's the simple way to say it. But 1 does not count as a prime number, so we're going to start with 2. Is this a prime number? Well, 1 times 2. Is that the only way we can do this? It certainly is. Well, let me get over here to this page here. Yeah. No. Here we go. So 2 would definitely qualify as a prime number. Okay. 3. 1 times 3 is the only way we can get it, so that's a prime number. Okay. 4. Well, 1 times 4, but then there's also 2 times 2, so that is not a prime number. We call that a composite. So you're getting a little mini lesson on prime numbers. 5. 5 is all you can do for that one. 2 times 3 is 6, so that would not qualify, would it? Okay, 7. The only way you can get 7 is 1 times 7. 8. 2 times 4, 3 times 3, 2 times 5. Okay, 11. I think you're going to notice that from here on out, it's only going to be the odd numbers, because anything that's even can be divided by 2 automatically. So, all right, so 12. 13. Yep, 13. 1 times 13 is the only way we can do that. 14, 15, 3 times 3, no. 17. Yeah, that's a prime number. 18, then 19. Yeah, that's prime. That's the only way you can get that one. 20. 3 times 7 is 21. 2 times 11. 23. Looks like that's prime as well. 24. No, that's even. 25. That's 5 times 5. 26 is even. 27. Oh, that's odd. Oh, 3 times 9. How about 29? Yeah, I think that is also a prime. And then 31. So how many did we get here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 out of 31. Okay, 11 out of 31. So let's put that down, and here we go. So the probability of prime is 11 out of 31 possibilities, and that's as far as we can go. So that is the reduced fraction there. So a little mini lesson on prime there. Alright, so our next example here is 2 dice are rolled, and what is the probability that the sum of the 2 dice on the next roll is at least 9? Okay? So all the different ways you can roll to get 9. How could that happen? So I got another little handy thing here that could be helpful to us for figuring that out. Okay, let me scroll up here. That's for a different issue. Okay, this little chart shows us all the ways. So we got, if you roll 1 dice, the second dice. So if you roll 2 1s, the sum would be 2. If you roll a 1 and a 2, the sum will be a 3. Okay, so how many ways that can you roll 2 dice? Well, the total is 36. Okay, so there's 36 total. Okay, but how many ways can we roll 2 dice and get a 9? Well, we get 3 times 6, 4 times 5, then 5 times 4, and then 6 times 3. So it looks like we're going to have 4 out of 36 possibilities here. Okay? Oh, I double checked and read the words. What did it say? It says at least. So what does that mean? We got to bring in some more numbers, don't we? Because 4 is not going to be big enough. So it's a good thing you always double check your words. Okay, so it's not just the 9. It's what? Anything that's 9 or more. So that means we're going to have to include all of these numbers here as well. Okay? So always good to recheck the words and to make sure you're answering the question as it was asked. So it said at least 9. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it ends up being 10 out of 36. So if they just wanted 9, we would have 4, but it said at least 9. So we got 10 instead. So let's get back over there. And so probability, and it would be greater than or equal to 9. That's how that would look. That's what at least 9 would be. And then we said that was 10 out of 36. And then that reduces to 5 over 18. Now, all that running around that you hear back there is that got a little dog, and she's decided that she needs to go out. Don't pay no attention to her, all that little grounding, but don't let that distract you too much. But I'm going to show you a little trick on how you can use your calculator to help you out here. And so we have 10. And then we can go to alpha F1. And then that's over 36. Okay. And then looky there, it reduced it for you. A little bit of distractions here along the way. But what if that gives you a decimal instead? Well, if it gives you a decimal instead, so this was a decimal, you could just hit the math button and see it says arrow fraction, and then just hit enter, and then hit enter again, and it would turn it to a fraction, a reduced fraction, if it can be done at all. It may not be able to be turned into a fraction in that sense. There are those occasions. So that's a good way to use our calculator to help us out. Now number 5, it says, what's the probability of drawing a heart or a club from a standard deck of cards? Okay. Well, we're going to have to do a little mini lesson on that too, probably here, aren't we? Okay, so let's come scroll down here. That's what this right here is for. Well, this first row is spades. That's a shape of a shovel, a spade. And these are diamonds. And then these are called clubs. Okay, these little clover looking things here. And these are hearts. Okay. There are 13 cards in each suit. Okay, 13 cards in each suit. So we're saying, what's the probability of drawing a heart or a club from a standard deck of cards? Okay, so hearts and clubs, how many is that? Well, that's 13 plus 13. Okay, so that's 26 total out of 52. Okay, because 4 times 13 is 52. So what's the probability of a heart, okay, or oh, that's an ugly club, but that's called I'm going to call that a club. And then we said that there were 13 hearts and 13 clubs, so that makes 26, and 52 cards altogether, hey, that's 1/2. So there's, if you randomly select a card out of the deck, half of the time you should expect to get one of those 2 suits. Getting a lot of little mini lessons here. Alright, so here we go. Number 6 in this simple stuff here. So there are 8 books lettered from A to H on the shelf. Okay. If Scott randomly chooses 2 books, what is the probability that he chooses books A and B? Okay. Well, he's going to pick how many? One thing. But how many different ways can you do it? So this is where it gets a little bit more interesting. It doesn't matter the order. So what we're going to do is, how many different ways can you pick 2 books? So that's called the combination of 8, pick 2. Goodness. So when we do the combination of 8, pick 2, let's grab that on our calculator real quick here. We've done this on a previous video, but let's remind you here. So I'm going to use the math button here. Math. And come over to probability. Number 3. And then it's going to be 8 over here. I'm going to put a 2 and hit enter. So there's 28 ways he could pick 2 books without really paying attention to what order they are in. So that's the same thing as saying 1 over 28. And that's a little different. Okay? And so, again, let's review what's happened. He's got 8 books to choose from. He's going to pick 2 certain books. Doesn't really care about what order. But how many different ways can he pick 2 out of the 8 books? So that's the combination of 8, pick 2. And he's only going to pick one of them, though. Okay? There's one way he could pull that off. Because it doesn't matter if it's A and B and then B and A. Alright. So that is some simple probability. Number 6 is a little bit more challenging on that end. Okay, so let's talk about the complement. And the complement is not just, hey, you look nice today, or those some nice shoes or whichever. The complement is what's not there. Okay, so in flipping a coin, what's the probability of getting heads? Well, that's heads. What's the complement? Tails. In rolling a die, you might talk about getting the probability of rolling a 1. Well, that's 1 out of 6. What's the complement? Well, what's the probability of not getting a 1? That would be 5 out of 6. That's kind of what the complement of an event is. So let's talk about the actual definition here real quick. It says the complement of an event is the probability that the event, okay, not happening. What's the probability of the event not happening? Since the sum of all possibilities is in sample space is 1, okay, the probability of an event not happening is P of squiggly E. So that's just means the complement. Also, what we can do is say 1 minus the probability of it actually happening. So if we subtract that off of 1, that'll give us what's left. Okay? So let's do some examples as always. It usually kind of helps us out. Alright. So the probability that it will snow tomorrow is 7 out of 20. 7 out of 20. What is the probability that it will not snow? Okay. So the way that would work is we do, what's the probability of this? So it's 1 minus 7 out of 20. Okay? So that would really be 20 out of 20 minus 7 out of 20. Because if the probability is 7 out of 20, that means it's going to be a 13 out of 20 chance that it will not snow. And what would that look like? So it would look kind of like this. A probability of S for snow, but we're going to put this little squiggly thing in front of it, okay? And that means not snowing, okay? So if there's a 7 out of 20 chance it's going to snow, there's going to be a 13 out of 20 chance that it doesn't. And that's how it would look like in math. But I think you can see how those two together, that's a yes and this is a no, how they should add up to be 20. Okay? Okay. And number 8, a month in the year is randomly selected. What's the probability that getting a month that does not begin with the letter A? Well, how many months begin with A? Well, we got January, February, March, April. Okay, we got April. June, July, August. Okay, there's another one. September, November, well, in October, and then December in there. So basically we got 2 out of 12. Okay, so alright, so the probability of not choosing a month that doesn't have an A is 1 minus 2 out of 12. Okay, so that ends up being 10 out of 12, and which reduces to 5 over 6, because we always reduce our fractions. Okay, and again, real quickly here, what would that look like if they were to use this probability notation? And they would say it'd probably look more like probability, and this is a little smaller, of not A. Something like that. That means what's the probability of choosing a month that doesn't start with A? And that ends up being 10 out of 12 or 5 out of 6. Okay, 2 more quick examples here, and we'll be done with this introduction to theoretical probability here. I'll pull it up. Yeah, we got enough space. It says if the spinner to the left is spun, find the probability that it lands on a number that is not prime. Okay, this idea of prime again. So let's go through and see if we can't find the primes. Okay, so 1 doesn't really count. So we got 2, 3, 5. Try yellow. See if that helps any. 2. That's not much better. 5, 7, 8, 9, 10, 11, 13. 14, 16. I think that's all of the primes. And again, we don't count the ones. So it's going to be 1, 2, 3, 4, 5, 6. 6 prime numbers. Okay. So if the spinner to the left is spun, find the probability that it lands on a number that is not prime. Okay? That is not prime. So how many numbers are not prime? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so our formula should be 10 over 16 when we're done. Okay? So the probability that the number is not prime would look like this. Would be probability not prime. Okay? I'm just, this piece for probability, that's for prime. Okay, let's get this a little bit bigger again. So that'd be 1 minus 6 over 16, because that's how many would be prime. And that would leave you with 10 out of 16 that are not prime. And that, of course, reduces to 5 over 8. So that's the probability of picking a number that would not be prime. Alright, so last one. 2 dice are rolled. What is the probability of not getting doubles? Not getting doubles. So let's go back to our little chart here and see if we can't find how many doubles we get. Okay. Roll this back up. Okay, so where would doubles occur? Well, 1 and 1, that'd be a double. Okay. And 2 and 2, 3 and 3, and 4 and 4, and 5 and 5, and 6 and 6. So 1, 2, 3, 4, 5, 6 out of 36 would give you doubles. 6 out of 36 would give you doubles. Okay, so change it back to a pencil. So we're looking for the probability of not being doubles, right? And so that would be 1 minus, so we said 6 out of 36 would give you doubles. And so whatever is left should give you the other number. So that would be 30 out of, what's 30 out of 36, right? And that would reduce to 5/6. Okay? So that'd be, so if you roll 2 dice, what's the probability of not getting doubles? Well, 6 out of 36 gives you doubles, so 30 out of 36 would not. So 5 out of 6 is what that reduced to. So hopefully that was a helpful introduction to theoretical probability and simple events, and then the idea of complement, the chance of something not happening. Okay? Thank you very much.